it's worthwhile.
I'm buying the winter set this year, so
Yeah, I bought myself a used set of winter tires, like the real honest to goodness ones, and
mhm.
I'm just gonna get them mounted. So, okay, it's time to start because Lord knows it's 5 o'clock on a Friday and none of us want to be here. So here we go. Hi, Anthony. Okay, so today, if there are any questions about the non-mandatory appendix assignment, we will get to that in the PowerPoint, so save your questions for then and we'll go over it. And then we're going to finish the safety valve bit, and then we're done with ASME. And what you're going to find is when we get into piping, which is our next topic, we've really covered a big chunk of it. One of the things that we'll do is we'll do more into piping calculations, and we'll compare B31.1 to ASME code section 1, and you'll get a better picture about the piping type of stuff. Now I do have that Kahoot challenge is up there, and today's the last day that you can do it. I think what I might do is I'll go online, and I think I can change the end date, so maybe I'll add another date to that if anybody's interested in doing it. And then the last thing is about the quiz reminder for this week. It's about ASME, and use all your resources. Okay, use your ASME mini BPVC. I don't think you'll need ASME 2 because if there's any question that has a stress value, the stress value will be given to you, so you don't have to worry about mean temperatures and you don't have to worry about uh, saturation temperatures and all that kind of stuff. The stress values will be given to you. I think there's only like maybe just a couple of questions, maybe like 3 different questions, whether you get all of them or if you get one of them. The quiz is going to be, I think, 20 questions out of 31. So it's luck of the draw whether you get one, but they're not terribly complicated. There's a head question in there, a couple of questions. There's a couple of drum, shell, tube type questions. And a lot of it has to do with, your understanding about what is the small letter E, is it the same as the big letter E? I don't know. Or the capital letter C, or uh, the little letter W, stuff like that. Not so much definitions, but maybe just demonstrate a little bit of understanding about what these terms mean. So let's go on now to that PowerPointy business. I kind of like the PowerPoint because it's like a teleprompter for me too. Plus, of course, it can demonstrate some things that are pretty hard for me to draw and time consuming for me to draw out. So here is where we left off. And so we talked about boilers and pressure vessels for that matter. Anytime we've got, I like the blue pen. Anytime we've got a boiler, we have to make sure that it has the proper set point on the safety valves and has to have the proper capacity. And so this is kilograms per hour, and this one here is kilopascals. So what it says in PG 67.1, and maybe what I'm going to do is back a slide here. PG 67.2.1, all of these different things here. Well, we're going to kind of peck away at most of them. So what it says is, of course, every boiler's got to have a safety valve, a pressure relief valve, and if it has more than 47 square meters of bare tube water heating surface, it needs to have 2 or more. So what we'll have is a steam drum, and it's got a valve over here. And okay, so in the Synovus building, boiler number 4, 2 safety valves? I think so. Why? Because it has more than 47 square meters of bare tube water heating surface. And if you like square feet, that's 500 square feet. Now, if it's an electric boiler, if it's an input power of more than 1100 kilowatts, you need to have 2 or more pressure relief valves on it. Next, 67.2. So this is about capacity. This is what set point. And it says the capacity, the pressure relief valves have to be able to discharge all of the steam that the boiler can generate. Now, they also have to be able to prevent the boiler pressure from rising more than 6% above the highest pressure relief valve set point, and to, in all cases, prevent the boiler pressure from rising more than 6% above the mop. So I'm going to draw a little chart here, and this is P, and on the bottom here is time, and I'm going to put a little dashed line here, and the dashed line represents the mop. And one of the things that I can do is an accumulation test. The accumulation test is all about determining if there is adequate relief capacity on the boiler. So here's what I'm going to do. I'm going to start with the boiler with no pressure at the beginning of the test, and I'm going to raise the pressure. And so I start steaming it and producing steam and steam and steam. And here's the thing. I've got the NRV is shut. And anything else that is consuming steam is closed, so no steam consumption at all. So what we're doing is confining all of the steam into the drum during this test, and it's called an accumulation test. So we raise up the pressure, and there's a certain tolerance in terms of when that valve has to pop. So we'll get to that shortly, but there's sort of like a lower popping pressure, and there's an upper popping pressure. So there's a range of acceptable tolerances for that valve to pop at. So let's say, for example, the valve pops there. Then what is going to happen is the pressure could rise. If the pressure continues to rise, I'm going to put this one here, this line, as being the mop plus 6%. Okay, if the pressure, it might do this and then just sort of level off. That means I've got adequate relief capacity. Or maybe the pressure might do this. Comes up, the valve pops, and the pressure drops down, the valve reseats, and then pressure rises, pops again, and resets. It might keep doing that. That means that I've got adequate relief valve capacity. So those are a couple of things that could happen when I'm testing the pressure relief valves. But if this happens, I raise the pressure, the valve pops, and the pressure continues to rise over 6% of the mop, that's a fail. And what that's saying is I've got inadequate relief capacity and I need to do something about it. Maybe put on larger pressure relief valves on the boiler. Maybe I can install another one. So if the boiler shell has another nozzle opening that's suitable for installing a pressure relief valve on, and it's being unused, well, I can add another pressure relief valve if necessary. So the pressure relief valve capacity has to be able to relieve all of the steam that the boiler can produce without allowing the pressure to exceed 6% of the mop. Make sense? Now, when you buy a boiler, it's going to have a nameplate on it. And that nameplate is going to say minimum relief capacity. That should be an R. So the minimum relief valve capacity. And it's going to be one of those little items on the nameplate. So you wonder, well, how the heck did the boiler manufacturer determine that? PG 67.2.1 says that the relief capacity must be equal to or greater than the maximum design steaming capacity as determined by the manufacturer. So this is kind of where we start. We start by selecting a valve that's got the appropriate steaming capacity based upon what it says on the nameplate. Well, how did they do that? What they did was they used non-mandatory appendix A44. Okay, that's what you had the little exercise on. So it's how much heat transfer surface there is in the radiant zone and how much is in the convective zone. So after they do the calculations, they estimate the steaming capacity and they say, this is your minimum relief valve capacity. But to validate it, to verify it, you have to do something like an accumulation test. Now, accumulation tests are conducted on high fire as well. Because it has to be the maximum amount of steam that the boiler can generate. So again, it says discharge all the steam that the boiler can produce. So let's skip that one. So here, in fact, is non-mandatory Appendix A44, and I don't want to spend a lot of time on it, but just check this out. So here we've got a listing of how many kilograms of steam per hour. In the little handout that I gave you, please beware that there are two tables that are identical, but one of them is in US standard units. You want to use the SI units. Okay, so kilograms of steam per hour per square meter of heating surface. So notice that the numbers are different for fire tube and water tube boilers. Most of what we're looking at is boilers that are oil, gas, or pulverized fuel fired. And then we need to take a look at these two terms, boiler heating surface and water wall heating surface. This is really weird because yes, they're boilers, right? But this one here really means convection heat transfer. And this water wall thing is you're thinking, well, fire tube boilers don't have water walls. No, they don't. But what they have is radiant heat transfer surface. So in the case of a fire tube boiler, this so-called water wall heating surface, it would be the furnace tube. So let's just compare them a little bit. A fire tube boiler, the radiant heat transfer surface, is said by ASME to produce 68 kilograms of steam per hour for every square meter of heat transfer surface. Water tube boiler, on the other hand, generates a lot more steam, 10 more kilograms per hour. And similarly, when we take a look at the convection heat transfer surface, fire tube boiler is said by ASME to produce 39 kilograms per hour versus 49 for a water tube. So I got a little question here. So here's one. Go ahead and do it. So we've got 35 square meters of boiler heating surface. It's fired with natural gas. It's a fire tube boiler. And so let's look at the fire tube boilers. And it's got a certain amount of boiler heating surface, 35 meters squared. And it's got 15 square meters of water wall. And so what is the minimum relief valve capacity? I don't know. 35 times 39 equals, and 15 times 68 equals, and then we add that up for a total. Sounds good. This is one of the things that was in that assignment that I gave you about non-mandatory appendix. Who's got the answer? Anybody? Jillian, you got an answer?
2,385.
2385 kilograms per hour. And so then the manufacturer is going to stick that on the nameplate and they're going to say that's the minimum leaf out capacity. You can have more, but you can't have less. Yeah, 2385. Okay. Now then, here's the same boiler, but you can use the same numbers, 35 and 15. This is a water tube. And this one here is fired on number 2 fuel oil. Well, it doesn't matter whether it's oil or gas or pulverized fuel. We're going to use that same thing there. And this being a water tube, we are going to have 35 times 49, and we're going to have 15 times 78, and we're going to get up with another total. And we expect this is going to be more than the fire tube rating. Who's got that answer? Say that again.
2885.
3885?
28.
2835. 2885.
2885, yeah.
Good job. Good job. Okay, so it doesn't get any more complicated than that. So now then, to prove that you have got the proper amount of relief capacity, there's 3 things you can do. First of all, the accumulation test, shutting off all the steam discharge. I went over it already, right? Or what we can do is we can measure the maximum amount of fuel that can be burned. Now this is in non-mandatory Appendix A12 and A17, where they say, okay, you burn so much fuel per hour, and this fuel has this particular heating value, and so then this is the amount of steam you should be able to be produced. So this is one way that's done. And the last one here is pretty good because we can measure how much feed water is going into the boiler. And if we say we're putting in 1,000 kilograms of feed water per hour at high fire, then that means we're producing 1,000 kilograms of steam per hour. So the last one here is by determining the maximum evaporative capacity by measuring the feed water. And again, if the capacity is found insufficient, just add some more capacity. Now this is all in A46, and it could be very helpful in an APS exam. So now we're done with capacity and we're on to set point. So one or more safety valves on the boiler proper. Boiler proper means the actual drum or shell. It doesn't mean reheater, it doesn't mean superheater, it doesn't mean economizer. This is on the boiler itself, the boiler proper. Shall be set at or below the mop. Now we know that 47 square meters is the trigger point for 2 or more safety valves. Okay, so if you've got 2 or more, one of them has to be at or below the mop. Call that valve 1. If additional valves are used, so valve 2, valve 3, valve 4, the highest pressure setting shall not exceed the mop. What? By more than 3%? So, okay, this is weird. Here's my drum. Here's valve number 1. And let's say my mop is 1,000 kPa. And then there's valve number 2. And that means this one here can be set to 1,030 kPa. And you go, what the hell? Yeah, we can have a valve on the boiler that is set above the mop. Not something we think about very much. Now, the third point under PG 67.3 says that there has to be a range of pressure settings. So all of the valves have to be within a 10% range of the highest pressure to which any valve is set. So this one here is set to 1030, and 10% of that is 10.3 kPa. No, no, that'd be 103 kPa. Okay, that's my 10%. So if I take 1030 minus 103, that'll tell me the lowest set point for valve number 1. So I could, in fact, have one. Remember, it says at or below the mop. This one could be as low as 927, and that one can be as high as 1030. That would be permissible. Any idea why you would want to have one valve set to 927 and the other one set to 1030? Okay, now that you thought about this a little bit, let's say I've got a total relief capacity required of 1,500 kilograms per hour. That's how much the manufacturer says. We've done a accumulation test. We've validated that yes, 1,500 kilograms per hour is just perfect for this boiler. Well, we can have a smaller valve at a lower set point, and we can have a bigger valve at a higher set point. Now, here's what's going to happen. Once we get to, the plus or minus of that 927 kPa, this valve is going to pop, and it might relieve enough so that this valve doesn't pop. That valve is small and it's cheap. No, not really cheap, but this one here costs a couple of dollars, and this one here, big bucks because it's a honkin' big valve. So how about we have a little valve that really does most of the work and is easy and cheap to maintain and repair and replace compared to the monster valve. So this is just one of the considerations. They permit this so that people can sort of run their plant a little bit more economically. Does that make sense? So here's a little summary. This is a good sheet for you if you're downloading this PowerPoint. 2 or more PRVs if you're over 47 square meters. One has to be set no higher than the mop. The other can be to no higher than the mop plus 3%. The range of set points is not to exceed 10% of the highest set valve. Pressure cannot exceed the lower set valve by 6% when relieving, and the pressure cannot exceed the mop by 6% when relieving. So now we're on to PG 68.1, which is about superheater safety valves. So you could have a valve there, okay? If we have a valve there, that would be called an isolable superheater, but I'm going to get rid of that valve. I don't want the valve to be there. This one here is basically our NRV, or our main steam stop. So here is valve 1, valve 2, and then there is the superheater safety valve 3. This superheater cannot be isolated from the boiler proper. There is no isolation valve. So PG 68.1 says every attached superheater shall have one or more pressure relief valves in the steam flow path between the superheater outlet and the first stop valve. There's the first stop valve. Now, as for set point, for kicks and giggles, let's just say that this thing has a mop of 2,000 kPa. Let's say valve 2 is set to 2060. Let's say that valve 1 is set to 2,000. Okay, so it's within the 10% range. This is A-OK. 1 is set to at or below the mop. This one here is set to 3% above the mop. This one here be set to, I don't know, 1,800 kPa. You know why, right? Anybody? Of these three valves, which one's going to pop first? 1, 2, or 3? 3. Right. So if valve 3 pops first on a pressure excursion, that means that we're going to maintain a flow of steam through the superheater, keeping it cool. Now, if this one here was set to, 2,000 kPa, we'd kind of have a problem, because let's say this one here pops first, because there's a pressure drop from the boiler to the NRV, to the superheater outlet. There's going to be a little bit of a pressure drop. So this one here pops first. And now in doing so, it starves the steam flow through the superheater. So typically the superheater safety valve is set to a lower pressure than the drum safeties. So then we get to capacity. I've got valve 1, 2, and 3, and let's say I need to relieve, 200,000 kilograms per hour. This is a small utility boiler. And now the question is, can I include that valve capacity in all of the capacity, relief capacity required for the boiler? And you don't have to. ASME uses non-mandatory language, and what it says, if you want to, you may include it, but there's a maximum. This one here can be attributed to no more than 25% of the total available relief capacity. That means that 75% of the relief capacity has to be on the boiler proper. So given these numbers that I just gave you, I said 200,000 kilograms per hour was the total relief capacity required. How much has to be here on the drum, and what's the maximum credit that can be given to the superheater safety?
So it would be 150,000 on the drum and 50,000 on the superheater valve?
Perfect. Exactly. So this one here, if I add up the nameplates here, I got to have 150,000 kilograms per hour. And this one here, if I look at its nameplate, it could say maybe 100,000 kilograms. Maybe it's a big valve. And then you go, oh, look, I got 150, I got 100,000 there, I got 250. Well, we can only say, even though it's a big valve, we can only say that 25% of the capacity is the credit that we give to the superheater. So we're only going to credit it with 50,000. Even though it's a big valve, we're just going to give it a credit for 50,000 kilograms per hour. Make sense? That's PG 68.2. Oh, and there's an example. I don't have to give you that example now. Okay, mounting. Do we put them on a mud drum? Do we stick them on a downcomer? Let's say I got a fire tube boiler, and here's my blow-off line, and I got two blow-off valves. Can I stick it there?
No.
No, no, and no. You're right. No, no, and no. It has to be mounted to the steam space. Not only that, they must be mounted in a vertical position. The spindle has to be upright and vertical. So I don't mount, I can't draw like that. Come on, David. Let's go like that. And then I got to make a triangle. Oh, I'm just blowing it. Okay. Okay, this is the way we want it to be. So what we have is a body drain. And so all of the water has to be able to drain out of the body as the pressure relief valve blows. Because if it doesn't, it just fills up with water, with condensate, and then it's going to rust and rot and corrode and seize the seat, and then the valve becomes unreliable. So it has to be in the vertical position. Now, it must be connected to the boiler as close as possible without any unnecessary pipe or fitting. So do I want to put an elbow there and an elbow there and a T over here and and then connect it to the steam space like that? That would be unnecessary, and we don't want any of those extra pipes. As close as possible to the boiler with nothing unnecessary in between. Now, sometimes, like if we need two or more pressure relief valves, you can mount them separately, so two of them on the shell, or you can make what's called a twin valve by putting them on a Y base. So here is a Y base, and it would usually have some flanges on it, and a mounting flange on the bottom where it gets mounted to the boiler flange. So bolts going through there. Okay, and then the safety valve bolted onto this one, another safety valve bolted onto that one. So that's a Y base, and that's acceptable as long as the area here, which we'll call area 1, it's a cross-sectional area, plus the area 2 for the other valve. Now we've got this common inlet. We'll call that area 3. And area 3 must be greater than or equal to area 1 plus area 2. Now this tricks people because they think of diameters. No, these are areas. So in other words, if I want to do this with internal diameters, so the diameter of 3 squared must be greater than or equal to the diameter 1 squared plus the diameter 2 squared. There's a pi over 4 in there somewhere, but it gets canceled out of each term of the equation. So keep in mind that we're talking areas. Now, how many valves? What kind of valve can you put between a pressure relief valve and the boiler? Or how many valves and what kind of valve can you put on the discharge piping of a pressure relief valve? No valve of any description. Okay, no valve. Okay, Here's another one under PG 71.3. It says the opening or connection between the boiler and the pressure relief valve shall have at least the area of the valve inlet. So sometimes we see a boiler and say it's got like an NPS2 nozzle, and somebody decides to change it out with a new valve, and this new valve's got a big honking inlet, and it's an NPS4 inlet, and they'll use like a reducer or a bushing or something like that to go from a small pipe to a large inlet for our great honking big pressure relief valve. And they think they're doing a good thing because, well, if a small pressure relief valve is good, a great honking big one is even better. But what they've done is they've choked the inlet valve so that the nameplate on that pressure relief valve, nothing, because the valve was never tested and verified and validated under those conditions. So here's the point of my story is we never restrict the inlet or the outlet. Never mind valves. We never restrict the inlet or outlet of a pressure relief valve. And we would restrict it with, say, a pipe fitting. Oh, I'm really messy today. Or outlet. Now, when you have a discharge pipe, the cross-sectional area shall not be less than the full area of the valve outlet. So in other words, you can't restrict the outlet. And if it has several valves feeding into it, it has to be of at least the total of the areas of the valve outlets that discharge into it. So here we go again. Now this is on the discharge side, so we got a common discharge pipe, A3, and we've got A1 and A2. So here I'm going to give you something. Let's say that this one here is 50 millimeters diameter. This one here is 75 millimeters diameter. What's the minimum diameter for the common discharge pipe? Who got an answer for me? Don't make me do the math. Okay, you forced my hand. I did the math. 90.1 millimeters in diameter would be required. So what I did was I circumvented the area bit because it would have just been, you know, pi over 4 and pi over 4 and pi over 4. Well, we can just get rid of all those pi over 4s from each term of the equation, and then we just end up working with the squares of the diameters. There's a sample question. And the same thing applies when we've got this Y mounting. So the inlet to these particular safety valves has to be greater than or equal to the sum of the safety valve inlets. Okay, let's back up a little bit to here, scooting ahead. Okay, gravity drains. Okay, every safety valve you've seen has got, if it's in steam service, got a body drain. Then same charge piping is going to have drains for condensate. Um, cross-section area. Okay, this is about inlets, and so we looked at the discharge and we looked at the inlet together. So we looked at the discharge first, and then we looked at the inlets, and it's the same principle. Which takes us now to operation, and I did mention something about set point tolerance, and then there's something also about blowdown. So here we got our pressure and time again, and so I operate the boiler. I raise the pressure. I reach a popping pressure, and then the valve blows down a little bit until it meets its reseating pressure. So the difference between the pop pressure and the reseating pressure is what we call the blowdown. So PG 72 is about how these valves are supposed to operate. And so pressure relief valves shall be designed and constructed to operate without chattering with a minimum blowdown of 15 kPa. So that's 15 kPa minimum. Or 2% of the set pressure, whichever is greater. So if I have a valve that's set to 2060 kPa, what is its minimum blowdown? I'll tell you, it's either going to be 15 kPa or it's going to be 2060 times 0.02. One or the other. What's it going to be? Are you going to make me do the math again? What's 2060 times 2%? Okay, 41 kPa.
40, yeah.
Whichever is greater. Well, 41 is greater than 15. So what this is saying is if it pops at, say, 2060, it can reseat as low as 2019. What if it reseats at 2000 kPa? Then what we have is a valve with excessive blowdown, and it's time to get the thing serviced or replaced, right? They have send it off to the valve repair company, and they'll service the valve and do whatever they need to do to make it behave the way it's supposed to. So in this case, this one here has 41 kPa of blowdown, and that's the maximum. Pardon me, that's the minimum. Excuse me. Okay, so then the next thing is about set pressure tolerance. They're just mechanical devices, right? So, how accurate do they respond to the pressure? So what we can do is we can take the valve off, we can put it on a bench, and we can put nitrogen underneath it and compressed air and cause this thing to pop, and then measure the pressure that the thing actually pops at. So this is from PG 72. And this little table here, let's just look at the MPAs. So that's 500 kPa. This one here is from 500 to 2100 kPa. This row here is from 2100 kPa to 7 megapascals. And then this one here is greater than 7 megapascals. So if the set pressure of my valve is 500 kPa or less, I'm permitted plus or minus 15 kPa. That means that it could pop at as high as 515 and as low as 485. And as long as it's popping within that range of pressures, it's okay. If it's popping outside of that range, then it needs to be serviced, replaced, rebuilt, whatever. Now, with the next range, it's not just a simple number, it's 3% of the set pressure. For the next range, it's 70 kPa. And then over the next range, it's 1% of the set pressure. So let's say that I've got a boiler that operates at 6,100 kPa. What's the maximum permissible popping pressure, and what's the minimum? Somebody do the math. Okay, there's your range. If it pops anywhere in that range, it's okay, it's acceptable. Now this is a great one because I love how some people think that the chief engineer of a plant can reset a safety valve. In PG 72.3, what it says is keep your effing hands off of it unless you are the manufacturer of the valve or you are the manufacturer's authorized representative or you are an assembler. So you have to have a V stamp. That's an ASME stamp. That would be the V inside of a lucky four-leaf clover, which I can't draw worth shit. Or you need to have a VR stamp. And a VR stamp is an ASME stamp, which means that you are an authorized valve repair agency. You don't get this for nothing, okay? You have to have all of the equipment, all of the procedures in place. You have to know what you're doing, and you have to be audited by ASME. ASME sends a representative to your plant and make sure that you know what you're doing, okay? You have to have this before you can change the set point of a pressure relief valve. Now, if you have one of those stamps, you can change the pressure set point by plus or minus 5% above the valve marking. Okay, you can go plus or minus 5% without changing the spring. If you want to go outside that range, then you probably have to change the spring, and you got to get the spring from the manufacturer. Now, one of the things that comes up, say, oh, the chief engineer can change the set point. No, the chief engineer cannot. The shift engineer can't. The assistant shift engineer, the maintenance mechanic, nobody can unless they hold all of that information. Now, once you make a change to the set point, you need to be able to install a new valve data tag. And you've got to reseal it. And we're done. Right on time. Is there anybody left in class, or did you all take off on me? Let me see. Let's see who's left. Oh, 17 of you left. It's wonderful. Have yourselves a great weekend.
Thanks, Dave. You too.